All right, so today we're doing nonlinear inequalities and we're doing rational ones where there's x's top and bottom. That means there's going to be critical values not only at the zeros, but also at the discontinuous places. All right, so that's the preview. But our warm-up, we're going to start with this problem off 17b. Oh, of course I don't have my tablet ready. Can you factor for me? Anybody? We can take an x out of the top, right? And then we'll have x squared minus 3x plus 2. And if we take an x out of the bottom, we'll have x minus 4. A little more on the top, and we get what? X minus 1 and x minus 2. Okay. So domain restrictions, I know it doesn't ask, but x cannot be 0 or 4. Does that mean that both of those are vertical asymptotes? No, because this factors the same top and bottom, so what's happening at 0?
There's a hole there.
Okay, and to find, once we've stated that there's a hole there, we can divide that off, right? And then we use the reduced one. If we put a 0 in here, I'll get -1 times -2 divided by -4, which would be -1/2. Did I do that right or not? Okay, so over 0 and down 1/2 is a big hole. We'll just make it that big. All right, what about vertical asymptote? X, I just lost my cursor. X equals 4. Okay. Zeros? Is 0, 0 an asymptote? Or a 0, sorry. We said that was a hole, right? At 0 there was a hole? Okay, so that doesn't, that's gone. So where are the remaining zeros? 1 would give us a 0 and 2 would give us a 0. So it crosses at 1 and at 2. Y-intercept? Is there going to be one, guys? If I go back and plug 0 into the original, I get 0 over 0. Remember there was a hole on the y-axis right here? What does that leave us? Oh, the fantastic end behavior. Okay. Do you want to do long division?
Not really.
You could do synthetic. You could do it right here, I think. Because this is going to drop out, okay? I'll do long over here. You guys do synthetic, and then we'll meet in the middle, okay? X cubed minus 3x squared plus 2x. I got x plus 1. Did anybody get?
Yeah.
Because everything beyond there would be remainder, and we get to throw it away. So end behavior equation. Y equals x plus 1, okay? So there is a slant asymptote that crosses at 1 and goes up 1 and over 1. What do you think? I think it's doing a little something something right down here and then probably up here. You guys type it in this time? Can anybody give me an ordered pair? Like if you put -2 in, what do you get? Anybody do a trace -2? -2 is an ordered pair? Okay. I was just trying to find a couple nice ordered pairs. What about -6? Okay, -6, almost to -6. So it's down here. Then we know it's got a hole. Now, what is it doing between 1 and 2? Is it just barely above? Thinking it must cross and go just a little bit above and come back? Like 1.5? 0.1? Okay, just barely crosses. What about 3? Where is it at +3? Oh, good guess how far. That's where I was headed. All right, and then it's going to get closer to that thing. Okay, now, what do we want to test to figure out where it is over here? Can we just type in like 5 and see what we get, even if it's not in your window?
12.
5, it's at 12. So I'm thinking there's a loop up here, and you could change your window to be higher, right, to see it. Again, not going to be on the quiz where it doesn't fit on your paper. Any questions? All right. One more warm-up that you don't have. If you want to write this, you might have room at the bottom of that page to write this down, but you don't have to if you don't want to. We're supposed to write a polynomial. Does that mean it's going to have a denominator? No. What's it called when it has a denominator with an x in it? Rational. Okay. So polynomial with a 0 at 3, a 0 at 4, a 0 at -5i, which automatically means +5i is also a 0. Now, how are we going to write this? How about +5i and -5i to start us out? And then we'll figure out what we should do, because this didn't go well. I got some really wackadoodle answers on the last quiz out of you guys. Just FOIL this together. X squared minus 5ix plus 5ix minus 25i squared. What does that become? X squared. Yes. I squared is -1 times -25 is plus. So some of you get that right away. Some of you need to write it out and do it, because I got some radical things. Like I got a lot of x squared plus 5. That's not right, right? Then we would have had answers like square root of 5. It doesn't factor. That's why we got imaginary answers. Okay? Why do I have to do that? Why can't I leave it like this? Yes, this means I can't leave i's in my answer. So that's pretty easy. We can do that. I didn't put one on there like -2 plus 3i and -2 minus 3i, which are horrible, but I don't want to grade them either. So the actual answers are nice, but foiling them together are miserable, and everybody makes the mistake somewhere. All right. Today's lesson. When we have a rational inequality, okay, something with a x in the numerator and denominator, or even just the denominator, you must include in our sign chart the zeros of both the numerator and denominator, okay? Because it says a polynomial only changes sign at zeros, a rational function can change signs at the zeros and at its points of discontinuity, so at asymptotes or holes. You can begin solving a rational inequality by first writing the inequality in general form with a single rational expression on the left and 0 on the right. So like a quadratic, guys, we want to be comparing this to 0. So if you look at the ones on your notes sheet, we're going to have to do some work to get them so they're compared to 0. All right, this is an example you don't have. If you'll just look up here for a second, we would want to combine these so we get a common denominator. So this one would multiply by x plus 1. This would multiply by x minus 6. They distributed, got 4x plus 4 and 2x minus 12. Combined like terms, we're to here. What are the critical values now? Anything that makes the top or the bottom 0. Positive 6. Negative 1. That doesn't look like a 1. And the top, let's see, 4/3, which would be in here somewhere, right? Okay. What are some values we would want to use our calculator to check? We could check 0 in here. What would be down here? Like -2 in here. 3 would, this is 1 1/3, right? So like 3 would work, or, and out here? Okay, 7, 10, anything. So let me see, can I copy that since we've done? So just kidding, here we go. Here's, I typed it all in the calculator, what we just found, and I put a picture of the chart here. So at -2 it was, can you see right there, guys? Negative, right? At 0, when I put in 0, I got positive. See, because we made it compared to 0, that's all we care about is positive or negative. 4/3 and 6, that doesn't, 4/3 doesn't show up as a 0 or an error because I didn't set the table to count by that, but it doesn't matter. All we care about, we were going to test 3 in there, and it was negative. Then out here, like a 7 or 8 or a 10 is positive. Okay, so this is the same thing up here, but we did it. Now, it said, where is it greater than 0? Okay, because it's greater than, we don't have to worry about parentheses or brackets. It's just parentheses. If this had said or equal to, what is the only value it could equal? Can it ever equal 6? Can it ever equal -1? But the 4/3 would have made it 0, right? So we would have wanted a hard bracket here if it said or equal to. If it didn't say or equal to, they're just all soft. But -1 has to be soft, and +6 has to be soft because the denominator can never equal 0. So if it had said greater than or equal to, would have had -1 to 4/3 bracket and 6 to infinity. If it just said greater than, we would have had all parentheses. Okay? I probably didn't make it or equal to on the test because it's a little tricky. All right. A rational inequality, one more time, can change signs at its points of discontinuity as well as its real zeros. So you must include the zeros of both the numerator and denominator in your sign chart. We good with this? Okay. So you have this one on your paper? Okay. So they started it by multiplying x plus 1 and x minus 4. Got this after distributing combined like terms, and we got to here. So what are our critical values, guys? +4, -1, and 3x minus 2 equals 0 would be +2/3. Everybody good? So what's something below -1? Right down here I have -2 was negative. What's something between -1 and +2/3? Okay, I put 0 in and got a +0.5. Between 2/3 and 4, I put in a 1 and got a negative number out. And past 4, I put in a 5 and got out 2 points. Okay. Can anybody tell what I did to get these? I did ask auto. Okay. So you can always do Ask Auto if you don't want to scroll up and down. All right, this question said greater than 0. So where are my answers? Where is it greater than 0 according to my little? Okay, so -1 to 2/3 and 4 to infinity. Is everybody okay? All right, is that on your paper? Here, -1 to 2/3, 4 to infinity, we good? This is what the graph looked like. That's kind of, the graph isn't going to tell me all that much for accurate values, right? I got to do some algebra. All right, here we go, number 5. They're going to start us off by throwing us in the deep end because it doesn't equal 0. So we're going to go x minus 1 over x plus 2 minus 3 is greater than 0. But what do we need to do with this? Get a common denominator, which is just x plus 2 over x plus 2. Are we okay? And doesn't seem that bad, does it? Okay. We're going to combine them. If I distribute on the top, I get x minus 1 minus 3x minus 6. Did I do that right? So simplify for me. -2x minus 7. Okay. Our critical values, one is at -2. I messed up when I did the top the first time. -2x minus 7 equals 0 would be -2x equals 7. So I get -7/2 or -3.5. I don't know if it'll, oh, it will let me move that. We'll move that over here. Because this should be -7/2 or -3.5. And -2 should be over here, and then 0 would be over here somewhere, right? Everybody good that our only two critical values are both negative? What's wrong? Ask, please. I moved the 3 over by subtracting it, and then we got a common denominator. X plus 2 was the only denominator. So then I took the whole top and distributed and wrote it over the denominator once, combined like terms. You okay? Anybody else confused about where a value came from? Okay. We need to type it in the calculator. We want to type this in the calculator, guys, if we're going to compare to 0. Hannah? Here, we were trying to get a common denominator so that we could combine the numerators. We put the x plus 2 over x plus 2 in there to get a common denominator. If we would have canceled, then we would be back to what we started with here. So we subtracted the 3 over to that side, and then we wanted to make it all one fraction. Better? Okay. Anybody else have a question? All right. We're going to not graph this, guys, because if we graph this, then we have to compare it to 3, and it gets complicated because the critical values aren't the same. So that's not even in our vocabulary anymore. We're down here doing this one. All right, so let's see. I think I typed it in to save a little time. What? Come here. Stop. It hates, oh, it's behind here. Something's going on. What have I done? I don't either. Where? All right, so I think I typed this in. Let's go here. All right, I got to turn it on because I got something else turned on. I typed them all in to save time. All right, so is this what we have currently? Negative 2x minus 7 over x plus 2. Okay, so I'm going to hit enter to graph that one. Actually, I don't even care about the graph. I did set my table to count by halves, or you want to do Ask Auto. If I would do one or the other, okay? I set the table to count by 0.5. Does everybody see where that is? I can make this bigger. If you go second zoom, right? Is it second zoom? Second window, thank you. Second window, you want this one to be 0.5s. Doesn't really matter what you start with because you'll be able to scroll up and down from there, but you want it to be counting by 1/2 if you're going to leave it on auto. All right. Are you kidding me? Got it. All right. So if I go to the table, what is something below negative 3.5? Negative 4, negative 4.5. What's it doing down there? It's negative, right? That's all we care about. Everybody good? Looking at the table? Here it's actually 0, which would only matter if we had an or equal to. Okay. In between negative 3.5 and negative 2 would be negative 3, yes? It's positive, right? And beyond negative 2, where it's undefined, so we can't include that no matter what, it's back to being negative. All right. So where is it greater than 0? Okay. And just for clarification, if it had said or equal to 0, which one of those could we have included? Yes, it would have been negative 7/2, but still parenthesis at negative 2 because negative 2 made the denominator 0. Okay. I did put an or equal to on the quiz, but it's on a polynomial one. So then you don't have to worry about the denominator business. All right. So you guys want to try this one on your own? Move the 1 over, get a common denominator, see if you can find the critical values. Madison. Is Alyssa the only one gone today? Okay. What happens? There is no x on the top. So we get, is it 6? So we have how many critical values? Just 1. Guys, why is negative 2 not a critical value? If this was a 0, it would be a critical value, right? But we're comparing to 1 here, not 0. So it doesn't, this is garbage. All right, when we get here, the only critical value is 4. How about we just do this one in our head? What do you want to try? 3. If I put a 3 in, I get 6 over negative 1, which is negative. What do you want to try on this side? Okay, if I put a 5 in, I get 6 over positive 1, which is, so where is it less than or equal to 0? Does anyone want to fix us? We can't, yeah, I was thinking we were going to need a hard bracket somewhere, but because it's a denominator, there can't be a hard bracket. If we put in 4, we get undefined. And if you look at the table, it will say undefined at 4, okay? But again, remember, if you're going to use the table, use it with this new one, not the old one. Because the old one was compared to 1, and that's not going to work. All right, what's the common denominator here? Okay, so what do I need to multiply the first one by? And the second one, x plus 2 over x plus 2. So that I will have a common denominator for both. What do I get on the top when I distribute? What did I do? Oh, this was a 2. Okay. I'm like, where did I go so wrong? So, okay, this was an x plus 2 in the original problem, so it's still an x plus 2. Okay, all right. Distributing the 1, distributing the 3, simplifying the numerator. Anybody? Did someone else get that or not? Okay, how many critical values? 3. Negative, I always have to do this one out. So negative 1/2, negative 2, and positive 4. Guys, do you see now where what I said yesterday is really important to put them in the right order, left to right, that if you mess it up, you're just messed up? All right, let's see if I have this one typed in. Is it this one down here? Okay. All right. If I look at the table, we could look at the graph, but if I look at the table, what's below negative 2? What's it doing? Negative. Between negative 2 and negative 1/2, what could we check in there? Like negative 1, it's positive in there, right? And between negative 1/2 and 4, it's negative again. And after 4, hey. Guys, I can't stress enough that you need to check every time, because it's possible that it doesn't always follow the pattern. We had one yesterday where it didn't follow the pattern because there was a bounce, remember? Okay, so don't assume that if it started negative, it's going to go positive, negative, positive. It probably will, but check the values, yes. All right, question was, where is it greater than 0? Negative 2 to negative 1/2 and 4 to infinity. And if it had happened to say greater than or equal to, anybody? What's the only one we could have put a hard bracket at? Negative 1/2. It would have been negative 2 to negative 1/2 with a hard bracket and 4 to infinity. It can never equal negative 2 or negative or positive 4 because it would make the denominator 0. All right, is there one more? Oh, lovely. Okay. Add 1 this time, right? Are they all greater than, or do we have some less thans? I feel like, okay, 6 was less than. Okay. We got to multiply by 3x minus 2 over 3x minus 2. Yeah, that's a hot mess. I don't know what that says. Something. What do we get on top? 5x minus 1, right? Because we're distributing a positive 1. 3x minus 2. Critical values are weird this time. What are they? So which one's further to the left? 1/5. What if you weren't sure? Yeah, give yourself some decimals to work with. Would that help? Okay. So critical points we could try. What do we want to try below 1/5? How about 0? Is that to the left? Can I just try 0? It would be a positive, right? I have it on my calculator, but I just was going to do some. Ew, I don't think I want to do this one by hand. What could 1/2 would fall in there, right? A 0.5? That would be 2.5 minus 1 would be 1.5 over 1.5 minus 2 would be negative 0.5, which is negative 3 to somebody who's checking their calculator. Negative. And after here, like a 1, we'd have 4 over 1 is positive. Okay. It was a greater than or equal to this time. Hard bracket only at 1/5, right? Can never equal 2/3. All right, are we including the positives or negatives this time? Yeah, we want the positives, so it's going this way and this way. So negative infinity to 1/5 hard bracket, but parenthesis at 2/3. Okay. Did anybody have any trouble with the first 5 on the worksheet yesterday? Okay. So you're going to work on the next 5 now. On the worksheet? Okay. Today you do. I'm going to go ahead and stop the recording because so this is what you need to do now, 6 through 10. Okay, guys? You just got to finish the worksheet. What? What did stop?